Hi, I'm Ezra. Today, I'll be talking about the chemistry of circuit boards. Now, before I begin, there's a couple of terms that I'll be using throughout the video that I'd like to define. The first is circuit board. This is a circuit board, or a PCB. PCB stands for Print Circuit Board. This is a raw circuit board. You'll notice how it doesn't look like the circuit board you might bust out of a TV remote or something, because, well, this one's broken, but you see how that is all soldered, and then you see how these are all here. These are called components, which leads us to our next word, components. Component. These are components. They are what makes the circuit board into an electronic. They do everything from creating light and sound. They read data and electrical impulses, and they do a lot more. Some common ones include switches, LEDs, ICs, which are a kind of microchip. Circuit boards make everything from computers to cameras, even those annoying remotes you have lying around everywhere that no one knows what they go to. Yeah, all circuit boards. But circuit boards wouldn't be possible without chemistry. So let's talk about the chemistry of circuit boards. The circuit board itself consists of two parts, the substrate and the copper foil. The substrate is usually made of silicon and some sort of epoxy. It is possible for it to be made of just pure silicon. Normally it is paired with an epoxy. The most common epoxy consists of epichlorohydrin and bisphenol. The copper foil is, well, copper. Because of metal's malleable property, it's simply smashed into thin sheets to the desired width. So let's talk about chemistry's role in the manufacturing process. First, the copper foil and the substrate are squished together, usually in a layering pattern. Because copper only needs to be exposed in certain areas of the PCB, and those areas need to be precise, a process called photoengraving is used. Photoengraving refers to a process that uses light to engrave. The photoengraving process does this through something called a photoresist. When a photoresist is exposed to a certain type of light, in this case UV light, it becomes more soluble. So, a photoresist is placed over the entire surface of the board. Then a pattern is laid over it. The pattern is clear in the parts where the copper foil needs to be exposed, so that when the UV light shines down, it hits the photoresist. Now, when the photoresist gets hit with UV light, it produces hydrogen cations and sulfonate anions. Hydrogen cations are acid. These diffuse throughout the photoresist, making it soluble. Then the pattern is removed and the photoresist is dipped in an acid wash. This acid wash washes away the already soluble photoresist, leaving the exposed copper. After a few more steps, the PCB is ready to become an electronic. Thus concludes my chemistry of ... project. Throughout this project, I've learned a lot about circuit boards and chemistry and the chemistry of circuit boards, and I hope you have too. Now before I go, there's two more things I just want to mention. First, I have to admit that it was really hard to get the circuit board out of the TV remote. Secondly, be sure to check out www.chemistryislife.com to see more on my chemistry project and many other projects like it as well. Thank you for watching. Bye.